Assalamualaikum and a very good day for everyone. So I'm teacher Nasreen. We are going to learn about group 1 from periodic table of the element happening. Okay, where is group 1? Here is group 1. Consists of hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Okay, but in our discussion, I only include lithium, sodium, potassium, rubidium, cesium and francium. Hydrogen will not be discussed. Okay, we have lithium Li, sodium Na, potassium K, and rubidium Rb. Cesium is Cs and francium is of Fr. So all this metal is known as alkali metal. These are metals, okay? Okay, uses of group 1 elements. Lithium is used in battery production. Sodium is used in sodium vapor lamps, and potassium is used in fertilizers. Electron arrangement. Why those elements in group 1? Because the valence electron is 1. Okay? But this is not a very stable electron arrangement. Every atoms like to just need to be like the noble gases element, which is duplet or octet electron arrangement. So what they do, like sodium atom, will donate 1 electron and become 2,8. From 281, it will become 2,8. So when you donate 1 electron, which is the negatively charged particles, you will be positive. Buang perkara negatif, kita akan jadi positif. Itu konsep dia. Okay, remember? So each group 1 atoms need to donate 1 electron and become a duplet or octet electron arrangement and become a positive ion. So semua dalam group 1 macam tu ya. Okay, now we go to physical properties of group 1 elements. We have lithium, sodium, potassium. The hardness is become lower, becomes softer. Okay, the melting point is decreased and also the density, apa yang also-nya, increase lah. So kita boleh buat conclusion ni semakin increase ya, even though 97 to 86 increasing generally. Physical properties of group 1 element. It is a soft metals, grey shiny surfaces, low melting and boiling points as compared to other metals such as iron and copper, low densities, good conductor of heat and electricity metals. So good conductor of heat and electricity. Okay, hardness, melting point and boiling point are decreased down the group, okay, from lithium, sodium, potassium, rubidium and cesium. The atomic size is increasing. The density is also increased because the size become bigger. Now we go to chemical properties. Okay, for chemical properties, we have 4 chemical properties. Just refer to previous experiment we have done. So lithium, sodium, and potassium have similar chemical properties but differ in reactivities. Down the group, reactivity is become increase. Okay. First one, we go to outside in the water tank basin outside the laboratory, and 3 of your friends that have lithium, sodium, potassium put those metal in the water outside the laboratory. Okay, so for example, here we have lithium react with water, it will produce lithium hydroxide and hydrogen gas. So that alkali metal hydroxide solution change color from change the red litmus paper to blue. Okay, red to blue. It shows that the water has become alkaline. Okay, the water through the basin. So if the metal is potassium, you will get KOH. If the metal is sodium, you will get NaOH. So depends on what reactant you use for this experiment. Okay, the second one, we burn the alkali metal in oxygen gas filled in the gas jar. Okay, so lithium react with oxygen, it will produce lithium oxide. Those metal oxide is a white solid. Okay, if the metal used is sodium, you will produce sodium oxide and so on. Okay, so biasanya 3 tu je lah. Now we go to the third one, solid metal oxide. Okay, from the experiment number 2 tadi, react with water, it will produce alkali metal hydroxide solution, which is LiOH. If you use K2O, potassium oxide, and react with water, you will produce KOH, potassium hydroxide. Okay, the fourth one, we take the alkali metal, for example, sodium here, react with the chlorine gas at the back. Okay, you will produce sodium chloride. What? Sodium chloride? Garam dapur? Tapi tak boleh lah makan sebab mungkin ada chlorine. Chlorine is a very poisonous gas. Okay, white solid metal chloride. So those 4 chemical properties you have to memorize, you have to remember, and you have to know how to write a balanced chemical equation. Okay, and you have to know the product. Why lithium, sodium, potassium have a similar chemical properties? Of course, because they have one valence electron. Okay, so all metals, alkali metals, which is lithium, sodium, potassium, have one electron in the outermost occupied shell, which is valence electron. Each of them react by donating one electron from its outermost occupied shell to form an ion with a charge of +1, thus achieving the stable octet electron arrangement. That's the purpose. Okay. Safety precaution in handling group 1 elements. All alkali metals are extremely reactive, so those metals must be stored in paraffin oil in bottles. Do not hold alkali metals with your bare hands. Use this forceps to take them, and remember to wear safety goggles and gloves. When conducting experiments, make sure that only a small piece of alkali metal is used, of course. Why the reactivity of group 1 element increase down the group? So this is an example of maybe a say answer. If the question asks you why down the group reactivity is increasing. So when going down the group, the size of atom become bigger, or the atomic size is increased. Okay. The distance between the nucleus and valence electron, this story is in an atom. Okay. Nucleus in the middle, valence electron in the shell of the atoms become far from each other, or further from each other, farther. Okay, hence the force of attraction between the nucleus and the valence electron become weaker, or just put weaker. Therefore, it is easier for the atom to donate the single valence electron to achieve the stable octet electron arrangement. So that's why it become more reactive down the group, easier to release electron. The activity of group 1 elements is release 1 electron. So this is some picture shows how the condition of the lithium after has been cut. So it shows the shiny surfaces, but the outer part of the metal is not really shiny because it has been oxidized with the oxygen outside in the air. Okay, this is sodium, and this is potassium, and this is rubidium. The oil is paraffin oil, paraffin. Okay. Rubidium and cesium is very reactive. Where is rubidium and cesium? Just at the bottom of the group. Okay, the end. Very reactive and burn easily. Usually combined with other elements, just difficult to be isolated chemically. Francium is unstable radioactive lagi. So with a short half-life. So that's why in laboratory it doesn't have any rubidium, cesium, and francium. We only deal with lithium, sodium, and potassium. I think that's all for today. Thank you.